Wonderful. Well, hello, everyone. Thank you all for joining us for the first installment of our new environmental webinar series titled Field to Cloud by Campbell Scientific, who is now celebrating our 50th anniversary. This webinar series will be dedicated to bringing you up to speed on the latest innovations in environmental monitoring. Today's topic will be Campbell Scientific's newest solution, the Aspen 10 IoT Edge device and its sensor solutions, along with its connection with the Campbell Cloud and CampbellGo. My name is Libby Anderson. I will be your host. Today, our experts, Product Manager Kevin Rhodes, Sales Manager Scott Bors, and Sales Engineer Brandon Terry will be guiding you through the Aspen 10 Edge device, which is now available for purchase. A few housekeeping topics before we begin. This webinar will be recorded and the recording will be sent out after the conclusion of the event. We will also have a live Q&A session at the end of this meeting, so please use the Q&A option to talk to our experts. And we anticipate the runtime to be close to 30 minutes as we know your time is valuable. So let's get started. Whether it's an individual sensor in a specific monitoring location or gap filling an entire network, the Aspen 10 IoT Edge device was developed so that users like you have a solution that is smart, easy to use, and dependable. But we're going to talk about what led to the decision to develop this device. So Kevin, what were the primary challenges or needs in the environmental monitoring sector that led to the development of the Aspen 10?
Good question. Before I go to the why, I'd like to just cover a little bit of history really quick. So Campbell Scientific, for many of those 50 years, we've been building automated weather stations, which are really, or the data acquisition part of those for several types of networks, climate reference networks, mesonets, road weather information networks, all sorts of networks out there using our data acquisition systems, which consist of things like this on your screen. So you have many sensors all going to one data logger and one power supply, et cetera, one telecommunication system. And so that's what we've been known for, and we've done that for a long time. And these are definitely important. They're the backbone of many, many climate networks. So you get all this data, and as this data comes in, inevitably you realize, hey, wouldn't it be nice if I could get the data just over there, just a little ways away, or I wonder what's going on over with this parameter over there. So to supplement this data, we call that's what Libby called gap filling. So spatially, you just have holes where you need to know a little bit more information. So the Aspen 10 was created as an IoT Edge device to allow you to take the sensor of choice and install it in your location of choice and not be tied to that, I guess you would say, traditional infrastructure of an automated weather station. So that's the first why. The second one is, as we go about that, we, instead of having this experience where everything's fully flexible and you can do whatever you want, we wanted to be an experience where it was just simple, that you could just go out there, install it, and you didn't have to learn. You didn't have to go to Campbell Academy, Campbell Scientific Academy, to get a degree on how to do this. So that was the second one. We want to make it just as simple as possible. So we came up with this, with the Aspen 10, out of the box in 10 minutes, 10 clicks. You're up and going and publishing data to the cloud. So the two purposes: your sensor where you want it, anywhere, and then just simple. In 10 minutes, you're there.
Awesome. Thanks, Kevin. And Scott and Brandon, how does the Aspen 10 address challenges differently from existing solutions?
Yeah, thanks, Libby. There are a couple of ways the Aspen 10 tackles these challenges. First, it dramatically reduces the deployment time and cost compared to traditional solutions. When we say field to cloud in 10 minutes, which I'm sure a lot of you have seen on our recent promotional material, we mean it. And Brandon will demonstrate this later in an onboarding of an Aspen 10, and you'll see how quickly and efficiently this plug-and-play technology really is. Second, with the Aspen 10 solution, The typical large footprint of meteorological stations, aren't needed. We see these images on the screen of existing med stations, and there's tons of cost with that, right? Infrastructure, planning, permitting, installation. However, with the Aspen 10, it can easily be installed on existing infrastructure or mounted to a simple fence post or T-post. Take for instance of adding a soil moisture station, like our soil view. All you have to do is drive a T-post in the ground, secure the Aspen with a few zip ties, and you're off and running. You only need a single field tech to install, which greatly reduces, the time and resources needed, extending your budget for additional stations or additional money, saving you cost or money in the end.
Awesome. Thanks, Scott. And Brandon, what additional information as far as installation and deployment should users know?
Yeah, so beyond what Scott just covered, the initial deployment time and cost. I guess we should mention the cost here, right? That we're talking about the money savings. So you're getting all these capabilities that are out there. That could be added right around $1,000. And that's for the hardware, the edge device, and the data for your first year. So all your data comms and software for $1,000. That's a pretty good value when you think about it. So let's dive into some of those advantages, right? So the Aspen 10, it eliminates the traditional obstacles like we just talked about. You want to have a sensor over there. We're always in the surface transportation realm looking to put a station in, but we always have to find that Goldilocks zone of, hey, the data is good here. We have power, we have comms, and it just gets crazy expensive, but you may not get it right where you want it. And that's what the beauty of the Aspen 10 is. You can put it right to to the spot you want. So that's pretty awesome, and that's something that we really look for. The Aspen 10 can be deployed anywhere. Scott just talked about, hey, T-posts, or you can stick it on a fence post, right? On the roadways, we have road signs, we have intersection signal poles. These are perfect spots for the Aspen 10. You can stick an Aspen 10. We can use a pavement sensor temperature and get data right where we want it. We don't have to worry about having a full ARWA station there. So that's pretty amazing. The economic impact of these stations, it's really substantial. And it's not just from the cost that we talk about. It's the opportunity cost. So using your people to plan out stations and systems and going out and getting these things maintained and taken care of, that takes time. Also, contractors, we don't have to wait. This thing, the simplicity that Kevin was talking about earlier, the simplicity of putting the systems in, you don't have to have a contractor or schedule all that. You can send somebody out to do a simple task, and while they're out doing another job, they can simply strap up an Aspen, configure it with their phone, and be on the move in 10 to 15 minutes. And you're saving that people time, and that's really important these days.
Awesome. Thank you, Brandon. And Scott, Brandon mentioned, the elimination of traditional obstacles, but could you go a bit deeper into some of those unique aspects of installation and deployment with the Aspen 10?
Sure. So when we say that the Aspen 10 is plug and play, we truly mean that it's plug and play. This phrase gets thrown around in industry a lot. It's kind of like this catchphrase. But here at Campbell Scientific, we stand by it. Once you have your account created, we do have this plug and play experience. And this is due to the plug and play technology that we are using with our specialized cables and sensors. So when you plug in a compatible SDI12 sensor to the Aspen 10, it automatically wakes up the device, queries it, and determines what sensor is connected. It then goes and downloads this recipe, right? And the recipe is a specified program for that specific sensor. So we download this recipe from the cloud and we start transmitting. It's that simple of connecting a sensor and getting that real-time data, right? We've talked about this already. This drastically reduces the time in the field and the technical experience that is needed, right? Literally anyone on your team, regardless of their experience, can deploy an Aspen 10.
Awesome. Perfect. Thanks, Scott. Now that we've established some of the unique deployment elements, Kevin, can you talk us through what sets the Aspen 10 apart from other IoT edge devices in terms of its connection to the CampbellGo app and CampbellCloud?
I will. So we have two companions here. This is the Aspen 10 is the hardware part, and it's the interface between the sensor and the cloud or your phone. So this little diagram here kind of shows that play. So we have two components: the CampbellGo app, which is your field companion. You take it out with you. It replaces, you don't have cables, you don't have laptops, you don't have voltmeters, all these other things. Your phone becomes all of that. And then the Campbell Cloud, which is your cloud component, which can be viewed from anywhere that you may be on a laptop or on your phone. So those are the two things we're talking about here. On the CampbellGo side, if you click to the next slide, Libby, thank you. On the left side is your field experience. On the right side is the cloud experience. So on the left side in the field, it's a Bluetooth connection from your phone to the Aspen 10. So you can know what's going on with the sensor. You can see live data updating rapidly. You can do diagnostics, everything there with your phone. And then the Aspen 10 is transmitting that same data to the cloud. So other people can see it, or you can see it as well using your phone, or disconnect over the Bluetooth session and you can see it in the cloud as well. And all this is made possible by over the cellular network. One of the differentiators, there are those who sensors or IoT devices that use LoRa, and then there's those that use the Cat M1 or narrowband parts of the cellular network. Nice part about cellular is you have plenty of bandwidth that you can pass data back and forth, where LoRa, it's one direction. You really can't talk the other way. So that's kind of nice. And the infrastructure is all there from the telecom companies. They've already built that in. So it's really beautiful and seamless. You don't even have to worry about it. So that's really nice.
So Kevin, you're telling me, like, when I'm out in the field and I'm using my CampbellGo app and I'm connecting to I'm connecting to an Aspen and I'm seeing the diagnostic information, and I may not be the most savvy person, right? We're just getting we're a field person putting this in. Can the people that's back on cloud, they can see all the data that we're talking about, cell connectivity, cell strength, battery power. Hey, if I need help troubleshooting in the field, my people in the Campbell Cloud, they can log in and look at that as like a single pane of glass. Is that what you're saying?
Yep, exactly. And the nice part is through the Campbell Cloud, you can look at all the stations or all the devices and compare all their battery voltages or all their air temperatures, whatever it is, and you can quickly identify outliers, all of those wonderful things that come with the gap-filled data as it comes in real time. So yeah, it's a pretty cool thing.
Yeah, that's awesome.
Awesome. Thanks, Kevin. Thanks, Brandon. So now that we've established what the Aspen 10 is and does, as well as its relationship with the Campbell Cloud and CampbellGo, we're going to have Brandon do a live demo setup of the Aspen 10 so that you can see how quick and easy it is.
All right, Libby, thanks. Here we go. So I'm going to share my screen from my phone here. Let's do that. And then let's go to our CampbellGo app. So the CampbellGo app is available via the Google Play Store or the App Store on Apple. So you can download them at either location, available for Android and Apple phones. I have an Android phone here, so I'm going to launch the CampbellGo app. There we go. It's going to go dark there. So that's kind of a security thing. All right. So you'll notice once you get into the CampbellGo app, you're going to be asked, this is the first time logging in, right? So, hey, what do you want to do? And so we have an Aspen device that we'd like to bring online. So you can hit the add button here on the screen, and that brings up the NFC. So this is the near field communication screen. And what this is going to do is it's going to start the connectivity or the pairing process from the CampbellGo app on the phone to the Aspen 10. So I'm going to touch it here to the side. You can see on the side there's a little antenna insignia there for the NFC communications. Okay. So once we connect, it's going to ask us, hey, what do you want to call this? So we're going to call this, we have a temp view 20 temperature sensor here that we've connected to the Aspen already. We're going to call this our temp view 20 demo Aspen. And you can name these whatever you like, something that just makes sense. So we'll call this temp demo, and we'll hit the next screen here. The next thing it's going to ask us, hey, is this a new station? So, hey, yeah, this is a new station. So I'm going to create a new station and call it a temperature station demo. And you can just do temp demo webinar. And you'll notice here in the GPS, and we'll talk a little bit about this in a little bit, but you can see that, hey, it's located where you're at. So when you fire up the Aspen and get it connected in, it's going to know where you're at because it has GPS functionality. We're going to click next. Okay, now it's going to ask us, hey, here's everything that we're going to be doing here. That all looks good. We'll confirm that. And then it goes in, hey, it's going to start going through the process. It's going to claim the asset, right? So this is we call the Aspen, we call these assets. It's going to claim that asset into your account that you'll create. It registers on the network. And Kevin's got some cool stuff he'll talk about with the cell communications here in a little bit. It says, hey, I've connected to the cloud. And you'll see it's already grabbed the recipe for the sensor. Now, you saw earlier when I was connecting into the Aspen with the temperature sensor, it goes ahead and says, hey, what are you when you plug it in? And it will say, okay, I'm a temp view 20. It'll go out to CampbellCloud. It'll pull the recipe down that you need for that sensor. Again, there's no need to know any kind of Campbell programming. This is self-configurable. It's really nice. Okay, you can click through any of these sections when it's going through the process and see what's going on. You can see it's already read the data, so that's good. And now it's fetching data from the cloud. So at this point here, it's sending the measurement that it just took from the sensor up to the cloud, and it's registering to see, hey, I'm sending data, and this takes anywhere from 5 to 15 minutes. It all depends on your cell signal and strength and your network speeds. And that's really about it. So you can see, as we talked about before, we set this thing up in less than 5 minutes. So pretty awesome.
Wonderful. Thanks, Brandon. Now that we've explored the Aspen 10's functionalities and benefits, and you've seen how the setup works, we're going to dive into some of its applications. And Brandon, will go right back to you to start on its impact in surface transportation.
Yeah, so in surface transportation, again, there's quite a few parameters that we use out there to help make great decisions when we're treating the roadways and trying to keep the roads safe. The Aspen 10 is compatible. We have a stack of sensors that you can see here on the screen. We'll start up here in that left corner. The WinterSense SDI 12. So that is an infrared pavement sensor, temperature sensor. It's got a air temp, relative humidity sensor in the back. So it's got a hydro view actually in the back of it. And it also gives you dew points. So all these are really critical measurements that are needed, especially during like frosty bridge applications. You know, when we're talking about this solution this is like less than 2 pounds. And then you've got the WinterSense is, you know, I think it's like 2 pounds. So you're talking like a 4-pound installation that you could put on a bridge and get that information that you need in these critical situations. So that's pretty awesome. I held up the soil view, so I've got this. This is a soil view sensor, and you can see all the different sensors that's along this, right? So this comes in a couple of different lengths, and it screws into the ground. You can see the screw head there. That gives us soil temperature, soil moisture content, conductivity, and all this stuff is great for, say, if you have permafrost and you have roads that have to close due to weight regulations during winter. That's great for that. And you can stick these things, like Scott said, on a T-post, you know, along the highway in different sections, and then go retrieve those if you want to in the spring. So that's pretty amazing. And then getting into, like, so we have the ClimaView sensor there, the ClimaView 50. You could use that for like gap filling in our, you know, Scott's got one there. So that's like an all-in-one little met station, right? It's got precip, it's got wind, it's got temp, it's got barometric pressure, There's a lot of little things this thing has. And I think it even has is that a pyranometer on top too? Is that thing it has?
Solar radiation.
Yeah, solar radiation. So we got pyranometer, a lot of values that you can get, and you can bring that into your meteorological applications, right, in surface transportation, such as your MDSS or your maintenance decision support systems and your forecast solutions of people that are out there. They love that data in those spots that are not around where your traditional ARWIS is. So that's a really good application as well. So again, by collecting this type of data from these different applications with the Aspen and those gaps, transportation engineers are going to be able to make those decisions to keep the roads safe for the motoring public, and that's pretty awesome.
Awesome. Thanks, Brandon. And Kevin, how does the Aspen 10 fit into environmental research and monitoring?
There are many applications, so I'll just focus on a few. Brandon already covered some of these, but if you take, for example, an ag researcher that's looking at soil conditions, so they could take that same soil view, place it wherever they needed it, and it could be under a pivot, it could be on bare soil, natural vegetation. Instead of having to create that area, you just take the sensor to that area and just put it there. So it's pretty sweet. Then you also don't have to worry about cable runs because it just runs to the Aspen. So they're co-located. You're not going to run over something with a tractor or have to worry about any of that. So you get your soil profile, you get the soil temperature, soil water content, soil permittivity, conductivity, all as a profile, and you get them in the exact location you want them. So that's one example. In almost every research, you need some environmental monitoring of. So you can pick the climate view, which you already talked about, and all its parameters. You can get all of the main met data parameters there, or you get a subset of that by going with a hydro view, where you just get temperature, relative humidity. If that's all you need, you just plug that into an Aspen 10 or just air temperature. So those are a few of the examples of how you could use that for data in research.
Awesome. Thanks, Kevin. And Scott, how does the Aspen 10 benefit applications as far as the hydrology industry?
Yeah, thanks, Libby. There's a lot of hydrology applications that we can use with the Aspen 10. First, let's take a look at the rain view. So the rain view is our newest rain gauge. You can see it here on the bottom right-hand side of the screen, right? It has that hourglass shape, right? And this is specifically designed to make it aerodynamic to reduce wind loading and allow for the most accurate precip catch without a windscreen. Also, the rain view also has a built-in digital processor in it, right? It essentially has a tip rate compensator. So, when you have high intensity rainfall events where you may have lost precip due to a typical rain gauge, it will compensate for that rain loss and give you the most accurate rainfall collection, outside of a rain gauge. So pairing the RainView 10 with an Aspen 10, network operators can increase the rainfall density over a drainage basin, right? This results in a more accurate basin averaging, which is really important when you look at urban flooding or reservoir operations. Think about all those high intensity small cell storms, right? With a more dense network, adding a RainView and Aspen 10, you're able to catch up those high intensity rain events that may have been missed otherwise with your typical rain gauge or mesonet network, right? And this also helps you with kind of ground truthing your radar for those specific rain events. One thing that also, when it comes to the hydrology side that we didn't mention earlier is the snow view, right? So the snow view is a great way to increase or get a better idea of your snowpack, right? Instead of deploying a full SNOTEL station, you can easily deploy a snow view with the Aspen 10. This is really a cost-effective way for that network densification, get a better understanding of your upper water basin, right? This is Mother Nature's greatest reservoir, right? It's an easy way to get a better idea of how much water is up there. And finally, let's talk stage. I know it's mentioned in the comments as well, but we're soon going to be releasing our latest non-contact water level sensor called the RangeView. So the RangeView is going to be smaller, it's going to be lighter, and it's more compact. And it also operates at 80 gigahertz. So what does that 80 gigahertz mean, right? So with that higher frequency radar sensor, you're going to get a narrow beam. So it reduces the chance of any type of interference or reflection of, debris or things in the water. Also consider if you're mounting it on a bridge pier or something of that nature, that smaller cone, there's less chance of reflection or having to get it out far enough from your bridge pier. So the range view will be coming here very shortly and is compatible with the Aspen 10. Finally, the other stage sensor will be our CS451 pressure transducer. And we talk about like a really economical way to monitor stage. With a CS451 pressure transducer and Aspen 10, you're out the door for under $2,000 to start monitoring stage levels in real time. So a lot of good impacts this has. For instance, irrigation districts can easily deploy an Aspen 10 stage sensor at any diversions or weirs. I was actually just attended a conference yesterday for a water conservancy, and they mentioned that they delivered water to over 200 endpoints. And these endpoints are everything from a large city to municipalities, other irrigation and water districts, or directly to farmers. However, their real-time monitoring ends at these endpoints, and it's the responsibility of the end user. So being able to deploy a cost-effective stage monitoring station here, really gives that end user that peace of mind and guarantees that, hey, we are seeing the proper flow rate, right? I am seeing water down this channel. It's not clogged, right? It reduces the need to be sending out water runners or people to check out each staff gauge, ensure everything is working properly. So a lot of exciting stuff in the hydrology market with the Aspen 10.
Yeah, you got my brain cooking over here, man. I'm thinking just for transfer, with that range view. So I'm thinking, flooded roadways, flooded underpasses, the small contact footprint. We're talking put the Aspen on the sunny side of the bridge, right, and then put a nice just a one little cable to a radar sensor. Now I've got a heads up when I've got problematic areas for flooded roadway and stuff like that. So that's great, man. That's really awesome.
Yeah, and what's cool with the range view is we've just specifically designed a new mount for it, right? So it's really easy to get your non-contact radar sensor leveled, because everyone knows that making sure that it's leveled when you're mounted to a bridge is key, and we've kind of rethink the way to do this.
Cool.
Awesome. Thank you all. So now that we've covered the applications and core functionalities of the Aspen 10, prior to going into our Q&A session, we're going to get a little bit more into the technical nitty-gritty. So we have a special section called the Geek Out, and here our experts will expand on some of the Aspen 10's more advanced features. So Brandon, we'll start with you quickly.
Yeah, so the NFC stuff, the near field communications, we'll talk a little bit about that. So the Aspen 10 has a Bluetooth radio in it, and that's how we pair CampbellGo to it to configure it. We don't want that broadcast out there. So that NFC, so the little insignia on the side here, works with most phones. You simply, when you touch the NFC or enable the NFC on your phone, you can touch the sensor and start the Bluetooth pairing process that allows you to talk securely to the Aspen 10 to configure it. And that keeps the public's eyes from coming up and trying to attach to your sensor when they just see something with Bluetooth and say, hey, what's that? Right. So that keeps that locked out, and that's real important. How do we get the data back from the thing? So the MQTT with the TLS, it's basically, MQTT is a standard-based, lightweight protocol messaging language that talks between like IoT devices, smart devices, your wearables, stuff like that. It basically allows devices to transmit using very little data, right? And that's what we're trying to maximize here. Is we don't want to use a whole lot of data because of power, because of bandwidth on networks. We want to get just the information that we need out of that, and MQTT is perfect for that. And then also it's a pretty secure language too, right? It's a machine-to-machine language. We want to actually put that in a wrapper with TLS so that the transport layer security, it's like it's a secure envelope. We're going to put our information in here. We're going to send it across the internet to the cloud, and boom, our data is going from the field to the cloud securely. We don't have to worry about anybody stealing or tampering with our data from one device to the other. So that's what kind of the package is with TLS with the MQTT.
Awesome. Thanks, Brandon. And Kevin, we'll move to you.
Thank you. I'll cover most of the cellular stuff. So Libby, if you see stuff in the Q&A that I don't answer, let me know. But I'll try and cover all those. So the cellular is, as I mentioned, it's a Cat-M1 narrowband modem, very low power, has a cellular antenna built into the Aspen 10. So you use this device as if it were an antenna. So you do have to have cellular coverage for this to work. It also has a worldwide or global SIM, what we call. So it's not an eSIM, it is a regular SIM. And we have agreements with companies that provide that coverage for wherever we take it in the world. So the hope is that you can take this sensor and Aspen 10 globally and have the same experience no matter where you go. So that's kind of awesome. And then the GPS, the modem can switch modes and it will go to GPS mode. And Brandon showed you how that works, that you can actually get the location of this device. And it'll just check GPS upon power up and then once a day after that. So it's kind of a secondary thing, but it's kind of nice to put a pin on a map. And you don't have to do it. It just does it for you. So between the CampbellGo and that. Are there other things in there that I...
No, I think that's about it. Kind of covers it. I think Scott can jump into plug and play.
Oh, there's another one. Let me talk about this SIM. So the SIM, how the modem works is it actually goes out and looks for available networks. If it finds a couple networks, it joins one of those networks, and as long as that network has enough signal strength, signal quality, and is allowed on the network in a certain amount of time, then we accept that and away we go. If that network should drop off or something happen, it goes out and looks for networks again and can join another network. So the nice part about the global SIM is you're not tied to just one provider in your area. So I think that kind of someone else alluded to that is, what if you don't have an internet connection? We're going to do all we can to find one for you. And that's all done over these lower frequencies that were left behind when people went to 4G, 5G, that are left back here for the IoT devices. And because they're lower frequency, they broadcast further and actually have better coverage or signal range. So at least in the United States, we have pretty good coverage.
Thanks, Kevin. And so what would happen if you're on one carrier and that carrier went down?
The modem would recognize that it's not getting the data through, and then it would reset, look for another network, and join it, and then start that process again. So
I saw that last night firsthand. I was going through and doing some stuff, and I actually saw the device switch over from the Verizon network to the AT&T network that was here, which is, I got to see it. I was wondering how that works, and it just automatically does it. So that's automagic, I guess we could say.
It's a pretty cool feature, right? Considering the redundancy that helps build in. So wrapping up here with the last Geek Out session, this plug and play technology that we keep talking about, right? Just want to lastly touch on the convenience of it, right? You plug in your sensor, it queries what that sensor is, automatically downloads that recipe and starts transmitting, right? These recipes that we're building, these programs, they're specific to what that sensor is. So we look at what the current consumption is of that sensor, and then from that we can know how to optimize the battery, the solar panel, to make sure that we have that extended battery life in mission critical situations, and that we're not overtaxing this device to pair with that specific sensor. There's really cool, unique things we can do with that, right? I think it was Brandon that mentioned earlier about, all this additional data. We get like MQTT success rate, battery status, like charge current, discharge current, battery percentage, health of the battery, right? And we can use that in our recipes. So for instance, maybe you deployed an Aspen 10 under a forest canopy, right? Where you may not get that greatest solar catch because you're trying to do specific solar moisture monitoring, right? And if you have a storm come through and you have lack of sun and your battery decreases to a specific point, with these recipes, we will automatically decrease the transmission frequency to help reduce that battery and current consumption to make sure that the life of this device extends. The other one thing to mention with this plug-and-play technology is, especially in the environmental field that Kevin was mentioning, is, if you have one of these out here connected to, say, a climate view, but then, you want to change your study and connect it to a CS451 pressure transducer, right? All you need to do is disconnect the previous sensor, plug in the new sensor, and it'll automatically recognize the device, download that new recipe, and start transmitting. So especially in the environmental market, it makes it really easy for short-term studies or things of that nature to take one device and move it around to different sensors. And the last thing I want to touch on before we wrap up and go to questions is that this is still a data logger, right? Campbell Scientific, we're known for our data loggers, and this thing is a data logger. So, we have the nice ability that both Brandon and Kevin mentioned. If we lose with this global SIM, if one network goes down, it can swap to another. But for instance, a network goes down and there's no other network available. Well, this device will keep reading that sensor, store it in the data logger, and once that network is reestablished, it'll transmit all that data. So there's absolutely no gaps in your data with that backfill. A great example is this: we had a whole bunch of Aspen 10s deployed on the coast of Australia, and they had a major cyclone go through that area, and both cell phone networks went down. However, we saw that once the networks were reestablished, all that data filled back in. There was no data loss. All the points came back in, and the Aspen 10 performed, pretty amazing paired with the climate view throughout that cyclone.
Awesome. Thanks, Scott. Thanks, Brandon. Thanks, Kevin. We did touch on a few questions, but we'll move into our live Q&A section for a few minutes. But rest assured, if your questions don't get answered now, we will follow up with you. But in the meeting chat, we've had quite a few great questions that our presenters should be able to see themselves as well to field through. But we have one question that asks, how many sensors can be connected to the Aspen 10, and how do sensors connect to the Aspen 10?
I'll take that one. So the answer is one. Yeah, just one sensor to an Aspen 10. And how it connects, I think they showed that already. It's a M12 8-pin connector with predefined pins. So you plug that in. One pin helps it recognize that it had something plugged in. Another pin passes the SDI-12 communication. Another pin has 12 volts or whatever the voltage requirement is for SDI-12 sensors. So that's what it does. It's just one, and that's how it works. So,
but you're not just limited to that, right? So you can have like a climate view, and you can get multiple parameters or multiple measures from one sensor, it's kind of nice.
Correct.
You're not limited to like one data parameter, which is nice.
Right. Yeah. So like the soil profile, that's one sensor, but you get 20 something parameters
Right.
from that one sensor. Very good point. So these are smart sensors, and the only limit is whatever the sensor is that connects to it.
Awesome. Thanks, Kevin. We've had another question. Is the Aspen 10 rated for hazardous atmospheres, Class 1, Division 2?
The answer to that is no, it is not. We haven't gone after that. This is mostly just for environmental monitoring. So we haven't gone after that rating.
Wonderful. And let's see, there's another question. I noticed when you were adding assets, the CR1000X showed up. Will it transmit the data tables from that logger?
It will, yes. So our regular data loggers are CampbellCloud compatible, or will be soon. So yes, that's a future thing. Brandon, you got to be careful what you show here. These guys are sharp.
They are sharp. They are, aren't they? But I also saw a question. So I saw something that somebody had a question about pulling the data out into another software. So let's just say you're a DOT and you have an ATMS software that's out there, or you use a provider. The CampbellCloud app actually has a fully published API. So you can use the fully published API and make calls to the Campbell cloud software and pull the data out for that asset. You call to the asset and pull the information out, and you can pull that data back into your existing pieces of software that's out there. So that's a really nice functionality of it. So if you want to complement the Campbell Cloud software with your own existing software, we do have the published API that'll do that.
And I think maybe it's the next slide. We'll show you a link to where you can access more of that information.
Yes. Wonderful. And that is all the time we have for questions today. If you had questions that we didn't get to, please reach out to our experts through the emails listed on the screen, and we will follow up with you. You will also receive a recording of this presentation and contact information in an email following this event. So thank you all again for joining us in today's Field to Cloud webinar session. We hope it was informative for you and look forward to continuing the conversation around new and innovative solutions in our next webinar. You can keep up with the latest events and information on our LinkedIn as well as campbellsci.com, and keep an eye out for our next webinar announcement. Again, you'll be able to follow up with our experts after this event, but thank you and have a wonderful rest of your day.